What's up, guys? Gonna make a quick video to talk about average rate of change. And yesterday we just spent a little time going over linear equations, and you might say, well, why were you going over linear equations? Well, we were mainly looking at slope, and lines have what you call a constant rate of change, like we discussed yesterday. It's called slope, right? Well, the problem is not everything is a line, not everything's linear. Some things are curvy, like a quadratic, or we've done exponential functions, all these things, and they change as the graph goes along. So in order to come up with like that rate of change, what we can do is find something called the average rate of change. And I want to give you some examples. Okay, so I want to start off with just a basic quadratic. Okay, so let's say we looked at like a y equals x squared, right? So you guys kind of know what y equals x squared looks like, right? Is this like a parabola with a vertex at 0, 0, right? So essentially, if you look at that graph, right? Say you're looking at y equals x squared. If you look at that graph, sometimes it's increasing, sometimes it's decreasing from left to right, right? Sometimes you're going uphill, downhill, right? Whatever. So it doesn't have like a constant slope. Sometimes it'd be steeper than other points, right? So what we do is we pick this little part of the domain, and we can actually find what we call an average rate of change. So I'll give you an example. Let's say we want to find the average rate of change from 1 to 3. And you might say, well, isn't that a point, Mr. Winslow? No, this is actually a part of the domain. So essentially what we're going to do is we're going to cut off this graph from like 1 to 3, okay? So, I don't know, like from here to here, say, right? Like, let's just say you cut it off like right through there, okay? And essentially what we're going to do is we're going to find a slope for those kind of 2 points, right? So the first thing you'd want to do in this situation is say, okay, we want to find the average rate of change from 1 to 3, right? So what you'd want to do is these are basically x values, right? So I would plug a 1 into this function first. So 1 squared would be 1, right? So on this graph, there's a point 1, 1, right? Because if you put in a 1, you get out of 1, right? Well, what would you get if you put a 3 into that graph? What's 3 squared? Okay, 3 squared is 9, right? So 3, 9 is another point, right? So you got 1, 1, and 3, 9, right? So this is how easy this is. All we're going to do now is just find the slope between those 2 points, 1, 1, and 3, 9. So if you do that, remember how it goes. You do y2 minus y1, so it'd be 9 minus 1, right, over 3 minus 1. So you basically get 8 over 2, which is 4. So basically what we're saying is from 1 to 3, you basically have an average rate of change of 4. So basically, like, if you drew a line from here to here, that line would have like a slope of 4. Okay? So the cool thing about this is it would change as you went along. So like, say you had that same function, right? Same function, and you say, okay, I want to find it from, I don't know, I want to find the average rate of change from -1 to 2. Average rate of change from -1 to 2, right? Okay, what that means is if you had this parabola right here, right? The same one we just had, right? The same parabola, okay? There'd basically be a point at -1, there'd be a point at 2, and you'd be finding basically that slope right there, right? The average rate of change, okay? So all you gotta do is plug these numbers into the function, get out your points, and find the slope. So let's picture this. If I put that -1 right here, right? What's -1 squared? Well, -1 squared is 1, right? So we got -1, 1. And what's 2 squared? Well, 2 squared is 4, right? So we got the point 2, 4, okay? See that? So -1, you put it in, you get a 1. 2, you plug it in, you get a 4, right? And now all you're going to do is you're going to find the average rate of change, or the slope, between these 2 points. So if you do 4 minus 1, that's a 3, right? 2 minus -1, 2 minus -1, that would also be a 3. And there you'd have a much lower average rate of change at just a 1, right? So basically that line is not as steep as the one we just did, right? So as you move to the right, you would see you get like a steeper rate of change depending on where you started. But all average rate of change is basically a slope for things that don't have a constant slope, right? You're just finding like an average slope between 2 points. Okay, so let me give you one more example, and I'll let you try some tonight for homework. But check this out. Let's say I had y equals x cubed minus x, something like that. X cubed minus x, and you remember what a cubic function looks like. It kind of squiggles like this, so it doesn't really have a constant rate of change like a line would, right? So what we're going to do here is we got to pick a part of the domain. So I'm just going to say, let's say from 0 to 3. Okay. So essentially what we're doing is we're going the average rate of change of this function from 0 to 3. So we're cutting this function off from 0 to 3, and we're going to basically find an average slope between those 2 points, right? So let's do this. If you put in 0 right here for this function, right? Remember, these are x values, okay? You put in 0 for this function. What's 0 cubed? 0, right? Minus 0, 0 minus 0 is 0. So if I put a 0 in, I get a 0 out. So that's 0 comma 0, right? Well, what if I put a 3 in here, okay? Help me out. What's 3 cubed? 3 cubed is 27, right? 3 times 3 is 9 times 3 is 27. And if I put another 3 right there, right? 27 minus 3 would be 24. So an input of 3 gives me an output of 24, right? Well, all you got to do is find the slope between these two. So watch. y2 minus y1, 24 minus 0, right? Over x2 minus x1, 3 minus 0, which is 24 over 3, which is 8, right? So the average rate of change from, in that part of the domain would just be 8, right? Now, would it change at different parts of the graph? Of course it would, right? Because sometimes it's steeper, sometimes it's not, right? But all average rate of change is you're kind of finding an average slope for a specific part of the graph, and it's literally that easy, okay? You're just finding 2 points and finding the slope between those two things. So if you can find the slope and you can put an input in, get an output out, you can do average rate of change, okay? So keep that in mind as you do your homework tonight, average rate of change, okay? Hope that helps, guys, and I'll see you soon.